Today we're doing hard problem 2528, maximize the minimum power at city. So we got some stations, and so we got some cities, and this stations array says that in city 0 there is 1 station, in city 1 2 blah blah. Now they provide power to nearby cities with radius r. Now the thing is, we can add k more power stations, so like increase total these numbers by k, right? Here k is 2, and they decided to add like 2 to this one. Now, given two integers r and k, return the maximum possible minimum power of city if the additional power stations are built optimally. Now the power received by a city is sum of those in range. So here radius is 1, so this, here it's this, here it's this, and so on. Whenever you hear minimum maximum, I already did this like 2 days ago, some problem. It's just binary search, right? Because if we can make the minimum power to be 5, it is also, we can make it 4, 3, 2, 1. So we are looking for the highest power we can make all. And now for a single power, can we check if we can make that station large enough, right? Now what we want to do is that we take the first look at the first station, right? We could compute like prefix sums to make it easier for us. Then we look for first station, so that's this range. And then we will be like, or we don't even have to do prefix sums, we can just take this. And we are like, let's say we are checking 5, and we are like, this is less than 5. So we need to add power stations to make it at least 5. Where do we add them? Well, we should add them towards the end, so that, because everything in here benefits, and if we put it at the end, most here, actually just this one, because radius is 1, will also benefit from increasing here. And then when we move, right, we always wanna add to the end, right? And if we cannot increase it enough, like k is not enough to increase it, then we straight up just return no, which means we need to lower the bound, otherwise we keep it same. So this is not a tough one, classic binary search problem. Binary search was one of those things that got me IOI in selection camp, where I solved one task which only one other person got. Some binary search on floating points. So wait, what do you mean? Know that you can build the K power stations in multiple cities? Like I can do like put them here. Okay, so I can split between cities. It's not great examples to understand it, but so what could be the power? I mean, if radius is large enough and we have k, technically it could be like sum of these plus n divided by k. So LR is 0, could be 0, yeah, 0 if we do k0 and station 0, and then sum of stations plus k divided by n. I think that's fair enough. And then here is what we are doing. So cumulative is this, and then we do for I in range n. Now we add to cumulative stations I. If we subtract, so if we are at position where, so with this it's 2 times k plus 1. So if we are over 2 times k, okay, that's fair enough. And then we are in here. Now if I is over k, then we have to do something. Or let's do like current, let's call this like current stations 0 times n, right? Now remaining is cumulative minus m. If remaining over k, r is, we straight up break, like we can is false and we break, right? Otherwise, if we have enough, then we want to put it to the last station, so which I guess is the current one. So maybe this should be like list stations, and then we use current stations, and here we also use current stations, and then what we can do is like current stations, so you'll have to subtract that, plus equals remaining current stations I cumulative sum plus equals remaining, and then we can do like if can we do this, else we do this. And then one more problem is that since we are doing else and we need to do plus 1 here, output 0. Print cumulative. Uh, 7, 1, 2, 6. So if, I mean, you cannot do 6, but you should be able to do 3. So 0, 1, 2. Cumulative is 7. Wait, how much is remaining? No, m minus this, so max 0, m minus cumulative. Because this is 7. And then how is this? Oh, so if it's with 2, then, oh, because I was, okay. Okay, so I need to actually transform k. Is this k divided by n really correct? Or I need to correct r. Oh, we are, okay. Radius. That's the first thing. And then we need to do, if like radius is 3, then we need to do like, oof. That sucks. I mean, not really, but if we are over radius, but if 0, 1, 2, 3, that's okay. So if we are here, we do this, and then if we are over radius like that, okay, first works, but remaining over k, yeah, we need some sort of current k 0, and then current k, and then current k minus equals remaining. Now this one doesn't work. That's awesome, bro. So cumulative is free. Bro, my radius was working. So first we have free, remainder of 0, I'm so dumb. Okay, now it should work. And you see, it's quite simple. Wrong answer. 12 test cases only. Really? No, it should be like that. Okay. I'm surprised it's straight up just, oh. By how much can you increase? I mean, if I have just one thing, I could increase by k, so I guess, but meh. What? So radius is 2. So I can take all this. What? Oh. This. I mean cumulative, and then why is it 56? Let's see. You shouldn't even be able to do 23, because I mean this is what 0 I current remaining I am, so what? So cumulative 33. Okay, we are checking 53, so we need to add 20, so we add 20 to station whatever 2, so it never runs out. And then you have what does that radius mean, bruh? This is weird. Oh, because I need to also shrink the window. Ooh, that's interesting. Maybe if I add like how much is radius? Radius is at most that, so I mean if I add stations 0 times radius, I thought that could do the trick, but it doesn't quite do it. Now we do TLE because whatever. Okay, should pass now. I mean, I'm kind of, this is probably the slow part, I think. And this is slow part. So I mean, a lot of copying, but I mean, who cares? This is like O of n let's do n space for sure on, right? So for maximizing minimum problems, always try binary search. Can make all cities have power at least k at least p. We can make them have power at least p minus 1. Checking if okay, so checking requires checking if all cities can have power at least p, requires using sliding window, and if any window does not have enough power, placing in total at most k stations. But where? Approach always place we should always place required powers sum of window minus, okay, so p minus sum of window max 0, and that and the in the last city in the window, since that makes that since that spreads their impact to most cities. To update sliding window, we can create a copy of stations where we add requ towers to current window end, and when it goes and when a station goes out, we remove it. We subtract also the edit stations and log m where m is. This can go to trash, this comment, and otherwise it's kind of easy. So if m is some stations plus k, since if we have one station, it can have at most m power, and we do binary search on power and on power in range 0 mn, and each iteration takes on to check O of n, since we are copying stations in each iteration, which probably could be avoided. I think it could, right? And then we do like stations I minus 2 times radius, because we could straight up do like remove, let's call it remove, and then remove, and then stations minus equals remove. Maybe. Okay, kind of works. Maybe like that. Who cares? Okay, see you tomorrow.